refraction of light at plane surface. So it expresses the beauty of the nature is made apparent with light. Light exhibits many interesting phenomena. Let us try to explore a few of them. Here we take some water in a glass tumbler, keep a pencil in it, a pen. Look at the pencil or pen from top of the glass. What you have observed? So there is some bend we have seen at the interface of air and water. I am showing that one as arrow mark. So in activity 2 we take a shallow vessel with opaque walls such as vessel. Coin, we confirm that it is visible and gradually hide and pour water continuously. You clearly observe that the coin is slightly appearing. So after pouring more water, it's appeared very clearly. So how does a light travel in different types of medium? So first of all, any light can travel different speeds with different speeds. So denser medium, the light travel slowly. In rarer medium, the light travels comparing to denser, it is high. So mostly we know that the high speed, very top speed of light can travel in vacuum only. So now, how does a light ray travel from one medium to another medium? So here we take two types of media, that is one is denser, another one is rarer. So first of all, we know what is rarer medium. A medium in which speed of light is more is known as optically rarer medium. One is denser medium. What is meaning of denser medium? A medium in which speed of light is less is said to be optically denser medium. We know clearly by taking an example for this. In air and water, air is rarer and water is denser. Let us we know how does the light traveling from rarer to denser medium. So take a glass jar. So this is a transparent glass jar. It can visible very clear from outside. So fill with water now. So this is water. Now take a torch. So this torch can focus the beam, laser beam. Take a laser beam, focus through the air now. So this is air and this medium is water. So this is the interface. This interface is separated the air and water. Now the light beam is passing in air now and it should be now touch the interface as or separated line or part of air and water. So this point we call as incident point. So that's why we draw a normal to the interface, this interface. So what is the angle formed here? 90 degrees. Now the angle between the incident line or incident ray to normal is now it should be angle I, that is angle of incidence. So now the light should be passed through the water now. So we observe that the this ray is called as refracted ray. So the refracted ray is bent towards the normal, and this angle is called angle of refracted, angle of refraction. So this angle we call as angle of incidence. So we confirm that here angle I is greater than angle R. Why? Because here the speed of the light in the air is very high. That's why the angle which is formed, the angle of incidence, is always more or greater comparing to angular. Why? The speed of the light in the water is less comparing to the air. That's why angular is always less to the angle I. Let us we know light traveling from denser medium to rarer medium. So in the second situation, in second case, we had to learn how does the light should pass from denser medium to rarer medium. So here also we take the glass jar, transparent glass jar, and put the torchlight the bottom of the glass jar now. So when the torch is switched on, the light beam, the beam of light should pass through the water now. So now here this is the interface. So whenever this incident ray is touched at a point of the interface, this should be incident point now. So this point we draw a normal now. Now the angle between the incident ray and the normal is now called as incident angle or the angle of incidence. Okay, now the light is now moving from water to air. So when it enters in the air, it should go far to the normal. So here the another angle formed, this angle we call as the angle of refraction, angular. Now comparing the angle and angular, here the angle I is less than angular. Look at here, in first case, in case 1, angle I is greater than angular. In case 2, angle I is less than angular. So the refractive index. What is called refractive index? The ratio of the speed of light in vacuum and the speed of light in any medium it traveled. So the refractive index indicated with n is equal to the speed of the light in vacuum by the speed of light in medium. that is the speed of the light in vacuum generally we indicate with C, and speed of the light in medium indicate with V. So refractive index N is equal to C by V. Here the C value in vacuum 3 into 10 to the power of 8 meter per second. The refractive index mainly depending on two factors. One is nature of material. The second one is the wavelength of light we use. Look at here, the wavelength of light is different. One light to another light. So we simply say that light is not a single one, it has combination of. Let us we know the relative refractive index. So to know that, we let the speed of light in medium 1 is take as V1, and the speed of light in medium 2 take as V2, then the relative refractive index comparing medium 2 to medium 1 is take as n to 1. So it can be write as, what is the first came, medium 2. That's why we write the refractive index of medium 2 by the refractive index of medium 1. So what is the formula for refractive index? That is C by V. So for medium 2 it should be V2 by for medium the refractive index formula is C by V1. So it can be write as C by V2 into V1 by C. C cancel. We get here V1 by V2. So the refractive index comparing the medium 2 to 1 is write as V1 by V2. If we write the refractive index comparing medium 1 to medium 2 is equal to medium V2 by V1.
ఈ వీడియో చూసినందుకు ధన్యవాదాలు. సో ఈ వీడియో మీకు నచ్చినట్టయితే కిందన్న లైక్ బటన్ని నొక్కండి. కిందన్న ఎర్రగా ఉండే సబ్స్క్రైబ్ బటన్ని నొక్కి దాని పక్కనే ఒక బెల్ ఐకాన్ ఉంటుంది. దాన్ని నొక్కితే మేము చేసే ప్రతి ఒక్క కొత్త వీడియోస్ మీకు అందుతాయి. ధన్యవాదాలు.